Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter number systems. Let's go for continuing this, and today is 8th period of this chapter. Dear students, please do remember we have been learning about this chapter in detail by solving plenty of problems, right? And yesterday we completely focused on fundamental operations on irrational numbers. I hope that all I have practiced well. And one more concept is there, just I had given you bit introduction only, that is about rationalization. What is rationalization? If irrational number is there, it should be converted into rational number. For converting irrational into rational, we go for multiplying another suitable irrational with the given irrational number. And this process is known as rationalization. Here we have the definition. I think you might have already written the definition of it. Just go through that. The process of converting an irrational number into a rational number by multiplying it with a suitable irrational is called rationalization. So rationalization is nothing but converting irrational into rational. Observe it. Here, just for the sake of understanding, I have taken one simple example. 7 into root 11 is irrational. We have to multiply a suitable irrational with another with 7 into root 11 to convert this into rational. See that I have multiplied root 11. Then root 11 into root 11 whole square and root get cancelled. 11 will remain. 11 into 7, 77, which is a rational number. See, this is the number we have multiplied with the given irrational to convert this into rational, and such number is called rationalizing factor. Do remember, the number which is multiplied to irrational number, given irrational number, to convert it into a rational is called rationalizing factor. I have written that definition as well. Then yesterday we learned one important concept, that irrational number is also to be considered with another name. What is that? It is surd. What is surd? Yes, the irrational root of a rational number is called a surd. What is its general form? General form is x into nth root of a, where x is coefficient, n is order, and a is radicand. If that surd is there, which is an irrational number, then what about its rationalizing factor? Here, rationalizing factor can be found out by using this. That is order and this is radicand. Radicand A raised to the power 1 minus 1 by order. This is simple method of finding rationalizing factor. And for if it is single term, we use the word rationalizing factor. If two terms are there, for example, 2 plus root 3, it is a binomial. And to find out its rationalizing factor, we go for using the word called conjugate. Clear? So later we come across this one. Here I have taken two simple examples to find their rationalizing factor. Observe it. Here, first one is 3 into root 7. 7 is there. We have to find out its rationalizing factor. How to find out? Here, root 7 is there, and this root 7 can be written as 7 raised to the power 1 by 2, because order is 2. If nth root of a is there, it can be written in exponential form as a raised to the power 1 by n. Here 2 is there, hence 7 raised to the power 1 by 2. We want rationalizing factor. How? 7 raised to the power 1 minus 1 by 2. Clear? 1 minus 1 by n, where n is 2. It is equal to 7 raised to the power, take LCM of the denominator, 2. Multiply LCM with the first term, 2. Multiply LCM with second term, 2 to get cancelled, 1. It is equal to 7 raised to the power 2 minus 1, 1 by 2. It is equal to What is 7 raised to the power 1 by 2? Again it is root 7. Therefore, rationalizing factor of 3 into root 7 is root 7 only. Understood? Okay. Next, I'll go for taking second one. It is cube root of 5. Cube root of 5 is given, and this cube root of 5 can be written as 5 raised to the power 1 by 3 because order is 3. We want to find out rationalizing factor. Then 5 raised to the power 1 minus 1 by 3. Write 5 as it is. Take LCM. 3 multiply 3 minus 1. It is equal to 5 raised to the power 2 by 3. And this can be written as it is cube root of 5 square. Then cube root of 5 square. 5 square is 25. This is rationalizing factor. We know that if it is a rationalizing factor, when it is multiplied with a given irrational number, then it gets converted into rational. Just for the sake of verification, here I am writing, it is the rationalizing factor. I am going to multiply this with the given number. What is the given number? Cube root 5. Rationalizing factor? Cube root 25. Then multiply. Orders are same. Cube root of 5 into 25. Cube root of 25 into 5, 125. Clear? Then cube root of 125 is 5. Because 125 is 5 cube. Cube and cube root get cancelled 5. Whether 5 is rational or irrational? It is rational. See that? We have converted irrational into rational. The same thing is also applicable to this. Now, I am going to write the list of the irrational numbers and you are going to write their rationalizing factors or conjugates. Here, then you all may be thinking that, sir, suppose binomial is there. I'll take a simple example. 2 minus root 3 is there. Then what is it? It is an irrational number. Then what about its rationalizing factor? Now you tell what should be multiplied with 2 minus root 3 to get rational number. I am going to take 2 plus root 3 as the rationalizing factor. See that? 2 minus root 3. See, this is the conjugate or rationalizing factor. I am multiplying this with the given irrational. It is 2 minus root 3 into 2 plus root 3. In which form? It is a plus b into a minus b. What it is? A square minus b square. Now, 2 whole square minus root 3 whole square. What is 2 square? 4. Then square and root get cancelled. 4 minus 3, 1. Whether it is rational or irrational? It is rational. Clear? Therefore, just you are going to change the sign. If it is minus, you are going to write plus. If it is plus, you are going to write minus. Understood? Okay. Let us go for listing them. What we are going to list? We are going to list out the irrationals with their rationalizing factors. Here I am writing. See that. Here irrationals. Then here rationalizing factor, also called conjugate. First example. First one I take, this is only nth root of a. Nth root of a, just we have already written, it is a raised to the power 1 minus 1 by n. Then it is root x. How do you write? This is x raised to the power 1 minus 1 by 2. When you multiply, when you simplify this again, it will be equal to x raised to the power 1 minus half. 1 minus half is half. X to the power 1 by 2 is again root x. So we can write the rationalizing factor of root x as root x only. Next, third one, 3 into square root of 5. Then rationalizing factor, root 5. It is just like root x. Then another one, very important, square root of a plus b. Will you write a minus b? No. Why? It is single term. Root a plus b. It is root a plus b only. Whereas root a minus root a plus root b is there. Then in such condition, what you will do? You can write it as root a minus root b. Here two terms are there which are separated by plus sign. When you are taking its conjugate, you are going to change just sign only. Next, sixth one. Suppose root x minus root 1. How do you write? It can be written as root x plus root 5. Are these not simple? Yes, they are all simple. These are the rationals and these are their rationalizing. So these are all irrationals with their rationalizing factors. So here you are going to write the heading that irrationals and their rationalizing factors. That is the heading. Okay, I hope that you have understood this. Now, so just go through that go through this one. First, we have written the definition of rationalization, converting irrational into rational. Then we have written the definition of rationalizing factor. Then after that, observe the general form of rationalizing factor. Here, x into nth root of a is an irrational and its rationalizing factor a raised to the power 1 minus 1 by n. Then we have taken few examples, only 2 examples to find out the rationalizing factor. Then after that, this table is very important. Observe it. We have written the irrational numbers and their rationalizing factors are conjugates. Conjugate, the word conjugate will be used when it is binomial. See that, root a plus root b, its conjugate, root a minus root b. Root x minus root y, its conjugate, root x plus root y. Yeah, copy from here, rationalization from here up to there. Okay, yes, just go for copying it. Now we are moving to the very important part of this chapter. With respect to rationalization only, we are going to take few examples. First, I have been taking very simple. See, first you understand the question. Rationalize the denominator of first one, 1 by root 2. See that, your numerator and denominator. Which is the denominator? Root 2. You are going to rationalize the denominator. That means you are going to convert the denominator irrational into rational. Now, this is the method. Observe carefully here. What is in the denominator? Root 2. What is the rationalizing factor of root 2? Yes, it is root 2. Just recall the table. Rationalizing factor of root x is root x only. Hence, root 2 is root 2 only. Now, observe this carefully. 1 by root 2, which is equal to 1 by root 2. I'll write it as it is. Now multiply rationalizing factor. What is rationalizing factor? Root 2. I am going to multiply to the numerator as well as denominator. Clear? This is equal to, what is 1 into root 2? Just root 2. Root 2 into root 2. It is root 2 whole square. Now this is equal to root 2 by square and root 2 get cancelled. Root get cancelled. 2 will remain. What is in the denominator? Yes, 2. So therefore, whether 2 is rational or irrational, it is rational. So, rationalize the denominator. Denominator was root 2 and it is rationalized. Got it? It is this 2 is rational. Is rational. Clear? Next, second one. Don't copy. Please observe the board. Here, second one is 7 by 2 into root 3. 2 into root 3. What is in the denominator? 2 into root 3. Whether it is rational or irrational? It is irrational. Now it should be converted into rational. Now I'll write rationalizing factor of the denominator 2 into root 3 is what? Whether you go for writing 2 into root 3 or just root 3. Just root 3 only. We never consider the coefficient. We don't want also. Here, root 3 is there. I'll write root 3. This is rationalizing factor. Now, next one. 7 by 2 into root 3. What is the next step? You are going to multiply rationalizing factor to the numerator and denominator of the given number. 7 by 2 into root 3 into root 3 by root 3. It is equal to. Now, 7 into root 3, which are in the numerator, I have kept them as it is. Then 2 is there. Then what is root 3 into root 3? Root 3 whole square. Square and root get cancelled. This is equal to 7 into root 3 by. Here 3 will remain. 3 into 2, 6. Then 6 is rational or irrational? It is a rational number. See the denominator 2 into root 3, irrational, it is converted into rational. Understood? It is very rare to give the problems like this, but this is somewhat we can say pretty important. Not much important, but in further problems we will come to know that. For that, these will be base, foundations. Observe. Here, what is in the denominator? 2 plus root 3. Whether it is monomial or binomial. Binomial, because two terms are there. Then you may go for using either RF, nothing but rationalizing factor, or conjugate. The most suitable word is conjugate. What is conjugate of 2 plus root 3? Yes? What do you say? As I said, you are going to change the sign only. Here plus sign is there. You have to write minus 2 minus root 3. This is RF. Next, here I will write 1 by 2 plus root 3. Again, I don't want to write again and again directly. I go for multiplying this rationalizing factor to the numerator as well as denominator. Here, 2 minus root 3 by 2 minus root 3, which is equal to, observe the numerator term, 1 into 2 minus root 3. All of a sudden, don't go for multiplying any number here with these two, because after simplification, there is a chance of cancellation. That's why you have to keep that number as it is. Then, denominator 2 plus root 3 into 2 minus root 3. In which form they are? They are in the form of a plus b into a minus b. Then, this can be written as a square minus b square. Hence, I can write 2 plus 3 into 2 plus root 3 into 2 minus root 3 as 2 whole square minus root 3 whole square. I hope that you have understood. Then, this is equal to 1 into anything is the same number only, 2 minus root 3. I have written this as it is. Now, apply square. 2 square. What is 2 square? 4. Here root 3 whole square. Square and root get cancelled. What will remain? 3. It is equal to 2 minus root 3 by. What is 4 minus 3? It is 1. What was in the denominator? 2 plus root 3. And what type of number is that? It is irrational. Now final answer. 2 minus root 3 by 1. What is in the denominator? 1. 1 is a rational number. That is just Q. Now you are going to copy first one, second one as well as third one. Okay. Just pause the video and copy all these quickly. Now observe, I have taken 2 more important problems. Here also you are going to rationalize the denominator. That means they have already given the denominator terms as irrationals. You are going to convert them into rationals. Now, look at it. What is in the denominator? 7 plus 3 root 2. Then what is its conjugate? Yes, conjugate of 7 plus 3 root 2 is just you are going to change the sign. It is 7 minus 3 root 2. Next, let me write the given number 1 by 7 plus 3 root 2. What is the next step? Just recall it. You are going to multiply this conjugate, nothing but RF, to the numerator as well as denominator. So 7 minus 3 root 2 by 7 minus 3 root 2. Hope that it's clear. It is equal to, observe numerator, 1 is there. If just only 1 is there, it does not affect. You can write it directly. 1 into 7 minus 3 root 2. Denominator, observe 7 plus 3 root 2 into 7 minus 3 root 2. Again, it is in the form of an identity. What is that? It is a plus b into a minus b, which can be written as a square minus b square. Now, this whole statement, denominator terms can be written as a square, that is 7 whole square minus b square, 3 into root 2 whole square. This is equal to numerator, let me write as it is 7 minus 3 root 2 because here 1 is there. Denominator 7 whole square. 7 square is 49, that is 7 sevens of 49. Now this is very important. It is, look here, square is there. This square should be applicable to both 3 square and root 2 whole square. What is 3 square? 3 square. It is 3 into 3. It is 9. 9. Next, root 2 whole square. Root 2 whole square, it is just 2. This is equal to 7 minus 3 root 2 by 49 minus, what is 9 2s are? It is 18. I don't have space. I am going to write here. But you should not follow writing in horizontal way. Now 7 minus 3 root 2 divided by 49 minus 18. 9 minus 8, 1. 4 minus 1, 3. 31. What is in the denominator? 31. What type of number it is? It is a rational number. Clear? Converting irrational into rational. It is rationalization. I go for taking another one. See, this time in the numerator we have taken 5. In all these numbers, numerator only 1 was there, but here 5 is there. Let us come to know how to solve this. I am going to put star mark for this, double star mark. Next, for rationalization, what is the very first step to be followed? Yes, you are right, taking the conjugate. Why should we take conjugate? Because in the denominator, binomial is there. Then if it is so, what is the conjugate of root 3 minus root 5? Yes, can you tell? Yes, you are right. Root 3 plus root 5, just changing the sign. Next, in another step, I will write 5 by root 3 minus root 5 as it is. Next, can you recall what is to be done? This conjugate should be multiplied to the numerator as well as denominator. For it is root 3 plus root 5 whole divided by root 3 plus root 5. Next, this is equal to numerator. As I said, don't go for multiplying this numerator term 5 with both the terms, because at last there is a chance of cancellation. You just keep that as it. 5 into root 3 plus root 5. Denominator, in which form? Again we have to write, they are in the form of a plus b into a minus b, which is equal to a square minus b square. Now I can write root 3 whole square minus root 5 whole square. It is equal to 5 into root 3 plus root 5. Square and root get cancelled. Square and root get cancelled. 3 minus 5. It is equal to 5 into root 3 plus root 5 divided by, what is 3 minus 5? Not just 2. 3 minus, of course you are going to find out the difference, 2. But what is the greater number sign? Minus. So it will be minus 2. This can also be written as minus 5 by 2 into root 3 plus root 5. What is in the denominator? 2. What type of number it is? Is a rational. So this is rationalizing the denominator. Clear? Dear students, again I have been telling, both the problems are very important. See, this fourth one, 1 by 7 plus 3 root 2. This is very important one, and its conjugate is taken. Then we have multiplied that conjugate to the numerator and denominator. Then using the identity a plus b into a minus b equal to a square minus b square, it has been simplified. At last you have got 31, which is a rational. And you just come to fifth one. It is 5 by root 3 minus root 5. To rationalize the denominator, again we have taken the conjugate of the denominator. Root 3 minus root 5 is written as root 3 plus root 5. It has been multiplied to the numerator and denominator. Then we have simplified by using the suitable identity. Then at last in the denominator we have got 2, which is a rational number. So now please pause the video and copy from there to here. Yes. Yes. One more important problem. Very important. So that I have put double star mark for this. Do you know why? Observe numerator and denominator terms. In the previous problem, we had taken just 1 in the numerator. After that, I increased that number, 5. But here, numerator and denominator, in both, we have binomials. Let us go for how to rationalize this kind of numbers. Rationalizing the denominator. So, what is the conjugate of denominator? Yes, conjugate of 6 plus 4 into root 2 is 6 minus 4 into root 2. Now, let me write that. The given number is 6 minus 4 into root 2 by 6 plus 4 into root 2. Still the next step. Yes, you are going to multiply conjugate or rationalizing factor to the numerator as well as to the denominator. 6 minus 4 into root 2 and 6 minus 4 into root 2. Hope that you have understood. It is equal to, now this is interesting one. Why? Observe the numerator terms. 6 minus 4 root 2 into 6 minus 4 root 2. In what form they are? Now first I will write it, then you are going to guess it. 6 minus 4 into root 2, this is repeated by 2 times, hence I write 6 minus 4 into root 2 whole square. Now you are able to recall it, is it not? Yes. It is in the form of an identity. What is that identity? Is a minus b whole square. Got it? Next, come to the denominator. Here 6 plus 4 into root 2 into 6 minus 4 into root 2. Purposefully I have written like this because we are going to use the identities at a time. Now denominator, in which form it is? Yes, it is of the form a plus b into a minus b. Now this is equal to, here we are going to use 2 identities. Numerator is of the form a minus b whole square, which can be written as a square plus b square minus 2ab. Already you are familiar with the identities. So first I am going to expand it by using that identity. A square plus b square minus 2ab. So if you go for writing like this, it will be easier for substitution. What is in place of a? 6. B 4 into root 2. A 6. B 4 into root 2. Clear up? Next, come to the denominator. Denominator is of the form a plus b into a minus b. So now a plus b into a minus b can be written as, yes, complete that identity. It is a square minus b square, right? Now just use that identity to write it in simplest form. It is a square minus b square. What is in place of a? It is 6. B, 4 into root 2. Clear? Now let me go for writing that here. This is equal to, it has been continued here. Now 6 whole square is there. What is 6 whole square? 6 square. What is the value of 6 square? It is 36. 6 square means 6 6 are 36. Understood? Next, here, this square, apply this square to both 4 square and root 2 whole square. Shall we write directly? Or if not, I will go for writing it separate. What is 4 square? 16. Into, see that, 4 into root 2 whole square. 4 square 16, root 2 whole square just 2. 2 minus, now see that, 2 6 are 12, 12 4s are 48. 48 into root 2. You can just check it. 2 6 are 12, 12 4s are 48. Whole divided by, now 6 whole square, it is 36. Minus, again, here 2 terms are there. Apply square to both. 4 square is 16. Then root 2 whole square is 2, which is equal to, now 36 as it is in the numerator. Then what is 16 2s are? 16 2s are 32 minus 48 into root 2. Next, 36 minus, what is 16 2s are? It is 32. And some student will go for committing a mistake like this. Here 16 into 2, here also 16 into 2. They will go for cancelling. 36, 36. So you have to avoid such kind of stupid way of calculation. So you cannot cancel them, because here the terms are separated by plus and minus sign. Here minus sign. Now this is equal to, what is 36 plus 32? It is 68 minus 48 into root 2 divided by 36 minus 32. Can we write 4? Yes. Then is it possible to simplify further? Yes. How do you say that it is S? Because in the numerator we have a chance to take out a common factor. What is the common factor? See that 68 is a multiple of 2. 48 is a multiple of 2. Even 68 is a multiple of 4. 48 also. Now, when you take out 4 as common factor, 4 1s are 4, 2 will remain 28. 4 7s are 28. Clear? Next, here minus 4 1s are 4, 2s are into root 2 divided by 4. 4 get cancelled. This is equal to 17 minus 12 into root 2 divided by 1. Actually 1 no need to write, but here in this case we need to write that one. The reason is we are going to show the rationalization of the denominator. Denominator is, this is irrational, it has been converted into a rational. Got it? Very important, it must be practiced. See that numerator and denominator in both binomials are there, and this is, and here we have used two identities. It is better to write the reason in the working column. That will impress the evaluator. Then please go for copying from there to here by pausing the video. Now we are moving to another important problem. Just observe, numerator note binomial 30 is the simple number, but denominator you can observe that here irrational with coefficients. Let's go for rationalizing the denominator of this problem. Here, first I write conjugate of the denominator. What is the conjugate of the denominator? 5 into root 3 minus 3 into root 5? Yes, you are right. It is 5 into root 3 plus 3 into root 5. In the next step, we are going to multiply the conjugate to the numerator as well as denominator. So, the given number is 30 by 5 into root 3 minus 3 into root 5 into 5 into root 3 plus 3 into root 5 divided by 5 into root 3 plus 3 into root 5. It is equal to, observe the numerator terms. Are they in any particular form? No. You can just write 30 into 5 into root 3 plus 3 into root 5 as it is. What about the denominator term? Denominator, obviously it is of the form a minus b into a plus b. Can be written as, it is a square minus b square. Here I will write a square minus b square, where a is 5 into root 3, b is 3 into root 5. This is equal to, I am not going to multiply 30 with both the terms. As I said, it should be kept as it is till the end. Reason is, at the last there is a chance of cancellation. Now, 30 into 5 root 3 plus 3 root 5. 5 root 3 whole square. 5 root 3 whole square. It is 5 square, means square should be applicable to both. Root 3 whole square. Square and root get cancelled. What is 5 square? 25. 3 root 3 whole square, only 3. 25 3s are 75. Hope that you have understood. It is 75 minus, what is there about this? 3 square, 9. 9 into 5, 45. Here I will write 3 into root 5 whole square, 3 square into root 5 whole square. Root get cancelled. 9 into 5, it is 45. I am going to continue that problem here. This is equal to, again write the numerator as it is, 30 into 5 into root 3 plus 3 into root 5. Denominator, what is 75 minus 45? It is, yes, 30. 5 minus 5, 0. 7 minus 4, 3. 30. See the 30 can be cancelled. This is equal to 5 into root 3 plus 3 into root 5 divided by 1, where 1 is a rational number. So we have converted irrational into rational. Okay? Yes. Now please go for copying this. It is also important one. By pausing the video, copy from there to here. Dear students, now we are moving to another very important type of problem. It is applied question also. Whatever we have learned so far, its continuation is here. Just go through that second question. Find the values of A and B. See that? A and B in each of the following. First one, 3 plus root 2 by 3 minus root 2, which is equal to A plus B into root 2. It gives the meaning that when you go for rationalizing this one, LHS part, you will get at last you will get a statement. It is after simplifying, that is after rationalization, you will get a final statement that will be in the form of A plus B into root 2. From using that, we can go for finding A and B. Let us see how this is. Very simple one it is. Here, you are going to take the conjugate of the denominator. Conjugate of denominator, that is 3 minus root 2 is, yes, 3 plus root 2. Hope that you have understood. Why we should go for rationalizing the denominator? The reason is this RHS term is in the numerator. Then it will be, if you go for simplifying it, it will be easier for comparing and finding the values of A and B. Observe it. Alright, 3 plus root 2 by 3 minus root 2. Multiply this conjugate to the numerator and denominator into 3 plus root 2 by 3 plus root 2. You can go for equating that a plus b into root 2, or at last also you can go for equating. Just let's go for writing in every step. It looks neat also. Now don't put equal sign here. This is the step. Already equal sign is here. Numerator, in which form it is? It is of the form a plus b into a plus b. That is a plus b whole square. So 3 plus 2 whole square divided by 3 minus root 2 into 3 plus root 2. It is equal to a plus b into root 2. Now, as the numerator is of the form a plus b whole square, you can expand it as a plus b whole square as a square plus b square plus 2ab. If you do not have space, here only you can put box and you can give the reason. Then it is of the form a plus b into a minus b, which is equal to a square minus b square. Let me go for writing there. It is, I'll write here itself. It is a plus b whole square, a square plus b square plus 2ab 3 root 2. 3 root 2. And this is a plus b into a minus b. A square minus b square. What is a? 3. B, it is root 2. And what is in the RHS? It is a plus b into root 2. And here we have written the reason. Next. Let me continue here. Don't put equal sign. What is 3 whole square? It is 9 plus root 2 whole square. Square and root 2. Root get cancelled. You will get 2 plus 2 3s are 6. 6 into root 2. Whole divided by. What is 3 whole square? 9 minus square and root get cancelled. Only 2 will remain, which is equal to a plus b into root 2. It is 9 plus 2 is 11 plus 6 into root 2 by, what is 9 minus 2? It is 7, which is equal to a plus b into root 2. Clear? Now, observe the denominator 7 is there. You can go for dividing the numerator terms by 11. As we have to express this in the form a plus b into root 2, I will go for writing separately like this. 11 by 7, 6 into root 2 by 7. It is equal to a plus b into root 2. Now compare the values of a and b. Are they not in the form of a plus b into root 2? Yes. Observe. I am comparing a and b values. On comparing, what is in place of a? It is 11 by 7. And what is in place of b? This is very important. Root 2 is here, root 2 is here. Neglect this. Remaining 6 by 7. These are the values of a and b. Dear students, repeatedly I have been telling, this type problem is very important in the examination point of view, as it is the application form type of problem. Here you are finding a and b values. So by simplifying it, at last you will get a final statement which is in the form of a plus b into root 2. Then on comparing a and b, you can go for writing the values. A equal to 11 by 7 and b equal to 6 by 7. Okay. Yeah. By pausing the video, copy from there to here. Okay. Dear students, here I have 2 more problems. I am giving these 2 problems for homework. Right? Look here. Very simple. However, we had solved in the previous problem, the same type are there and follow the same steps. Then go for finding the values of A and B. And for verification, even I have given the answer as well. See that for first one, root 3 minus 1 by root 3 plus 1 is equal to A plus B into root 3. After finding, your answer should be this one, A equal to 2 and B equal to minus 1. And another one, 5 plus root 6 by 5 minus root 6 equal to A plus B into root 6. And for this, the values of A and B are, A is 31 by 19 and B is 10 by 19. Okay. I hope that you have understood, you are able to do this. And equal sign is very important. And in each line, there must be only one equal sign. And the method of solving is very simple. Rationalize the denominator. At last, whatever the final answer you get, compare that with A plus B into root 6 and find the values of A and B. And dear students, before concluding the class, let me remind you one important thing. Whatever the problems we have solved today, please practice them today itself. Don't keep anything pending. And in today's class, I know that you might have experienced that little bit more work is there, more writing work is there. You need to practice as many times as possible. Got it? So with this, let us stop the class. Thank you.